Hey, what are you doing out there? You need to be in here at Architect Live. If you don't get in here, you're going to miss a fascinating presentation done by Virginia Tech's own Joseph Wheeler on net zero energy and sustainable dwelling. All right, take it away, Big Joe.
Thank you very much. That introduction was a design by Joe Wheeler. It's actually designed by a team. It's a team at Virginia Tech, a team of students and faculty, and we would say also a team with the industry and with the profession. The Virginia Tech Lumen House was initially this is not the Virginia Tech Lumen House, by the way. It was initially a project for the Solar Decathlon competition. When we began designing this project, we were inspired by Mises' Farnsworth House. The pavilion-style architecture, the openness, even early ideas of passive design, with the tree on the south side. So we started with this inspiration, and what resulted was a design that utilized an idea we call responsive architecture. It's a house that's very open. It's got north and south glass, but has this safeguard that if the weather turns extreme, you have insulation and you have shade that can close down and protect the house during the extreme weather. So that was the vision, and this is the final product. It's a very small house, only 600 square feet. Could you go back one? It's only 600 square feet, and we wanted to spread a message or make a statement of what we should be thinking as far as energy and sustainability. First is we don't have to have houses that are so big. So a very smart floor plan. This is it's an open plan. It's very much also inspired by Mies. But you can see there's a north and south glass facade that allows the house to expand to the bigger decks on the north and south when the weather is good. So you can see the openness, from the glass. We also want to take advantage of technology to help us, assist us with energy efficiency. So we have a building control system by Siemens, also a corporate sponsor. They did the best. Rather than just giving us money, they actually gave us a technician that worked with our students for years, actually, on developing this home control system. But it's a management. It helps us manage energy, but also all our systems within the house. One of the also very important parts of this is information that we can provide to the homeowner. If the homeowner knows where they're using energy, they're more likely to be able to adjust their habits to live a more energy efficient life. So the iPad, which is the interface to that building control system, gives us all of that information. When you leave a light on, you can actually go to your iPad and look and see what the result of cost and energy use for that mistake. So the iPad also acts as an interface to override some of these systems. So the responsive architecture part, I'll move back to it. This is a weather station that's mounted on the corner of the house. It's monitoring temperature, humidity, wind, daylight, rain. It's sending all that information to the home control system. And the house has different elements that respond to that weather. So we have shade screens, we have insulation panels, and we have sage glass. We also have an operable, a movable photovoltaic system that responds to the time of year as well. Many different systems throughout the house that respond to this data to save energy. So here you can see just the opening and closing, the insulation panels, the shade panels. They're the three together. We even have electric draperies, which open and close. Insulation panels are filled with aerogel. They're polycarbonate panels. That gives us an R24 value when these things are closed. So the photovoltaic system, like I said, will raise and lower between winter and summer. It adjusts itself approximately once a month. And the sage glass over the kitchen protects the inside of the house, the kitchen, during west, harsh summer light. The idea is that you'd have a daylight sensor, and that linked with your building control system knows when that should be on and when that should be off. There's also other ideas in the house I'll talk to about in a minute. It's on industrialized processes, on how this house is not just a one-off or just a, this could be a potential ideas that can lead into mass production. So the Eclipsis system, I'll talk real quick about it. It's a shade system that was inspired by the Majrabia, the Arabic shade screens that give you, privacy. It gives you shade. It gives you cross ventilation, and it has depth. The screens have depth. So our innovation was this disc that turns, and when that disc is turned, it's basically accommodating the shade for the opening that it made. And we have patterns on there that respond to even other ideas about the house, such as views from inside, and also cross ventilation. Like for example, at night you can close the shade screens, but open your sliding glass doors with the bug screens, and you can get a cross ventilation while still having security, for example. Backtracking, we used aerogel in many different kind of areas of the building. We even experimented with filling insulated glass units, increasing the R values and still providing lots of natural light. The landscape we used, could you go back one? The landscape was designed to filter our gray water. We also collect rainwater from the roof into a cistern for filtration and reuse. And like I said earlier, there's lots of ideas behind how this thing is manufactured and could be a concept for modular prefab housing. One concept we have is called luminosity, where we can start to think as the family grows, you can build up the size of your house, but then you're not stuck with the big house. So if it's a development with many of these, you could eventually sell them off, put them on eBay or. And then there's ideas of space planning. I'm sorry, excuse me. Didn't turn my phone off. Furniture systems that save space or allow reuse of spaces, like your dining room can shrink while your living room expands, or your kitchen and dining area expand, reducing the size of your living room with easy moves of furniture. So the interior design component of this is pretty clever, like closets that open up and also become doors for privacy. They allow a bedroom to become a sitting room during the day. And those doors also, provide storage. A bed that folds up by day and converts by night. So you don't need as much space, for your house if you can utilize that really efficient space better. A desk that converts to a hallway. So a hallway becomes a home office. A small bathroom that has beautiful light. It's a vertical skylight that allows you to see the photovoltaic technology. And one of the more innovative and more fun parts about this house is the strategy for winning the competition was to develop a strong kind of structural idea on how this thing would be transported. In the many decathlons that we've competed in the past, we finally learned that the best way to compete in these events is to arrive to the site, to the competition, completely finished. So we work with Ove Arup's office, and we developed a structural kind of idea, a concept based on the double drop lowboy chassis, which is the center of the structure is the house. So the house doesn't sit on a flatbed, it is the flatbed portion of a double drop. When it gets to its site, those two pieces, the gooseneck and the bogie, remove, and it's ready for competition. So there was absolutely no work inside the house that we did during the 7 days that we had to set up. And this was really the make or break for the competition. It worked out well. But also because of that idea, because of that concept, this house is extremely transportable. And after the competition, it started receiving much attention, and we had requests to take it to different places. This was just the frame moving from a plant. We were testing the idea of prefabricated, this modular construction. So to start it off by just making the frame at a plant to test that, moved it to our campus, and in about a half a year, 3/4 a year, we finished it. So this is the house getting off the ship in Madrid, Spain, heading to the competition. Since then, it's been in Madrid in the competition. It's been on our own drill field after winning the competition to celebrate in Blacksburg. It's been at the National Building Museum as part of the Sustainable Communities exhibition. It's been on the mall in Washington, D.C., in Times Square in New York City for the Good Morning America show. That was wild. It's been on Millennium Park for the USGBC Green Build. And finally, this was great. I started this little presentation out with the image of the Farnsworth House. We got a call from the Farnsworth House, and they said, we've been following you. We know you've been inspired by this house. Could you bring it here? And we said, absolutely. This is like the best. So not long after this exhibit, we trekked out to Plano, Illinois, and we exhibited at the Farnsworth House. And just recently, just a few months ago, it returned to campus. That's where it is now. And we use it on a day-to-day basis to develop our research, to continue to fine-tune, and actually to move to our next project, which is concepts on industrialized housing related to energy efficiency. So thank you.